This is percent composition. That's where we find the percentages of each element in a compound. It's no different than finding the percentages of anything else. If you find the percentage of your grade, it's how many points you have over the total amount of points. The same thing for this. It's a percentage of an element, how much mass of an element you have in a total mass of the compound. The percent mass of the element equals the mass of that element over the total mass of the compound times 100. So for example, if we want to find the percent composition of water, we want to find the percent of hydrogen and the percent of oxygen. So we find the mass of that element, hydrogen over H2O times 100. And the same thing with oxygen. All right, so let's look at some examples. If we had 71.2 grams of nickel and 35.4 grams of oxygen, what is the percent composition? Now this is the easiest one. We're given the masses already, so even without knowing any of this, you could probably figure out what the percentage of each would be. So percentage of nickel is, what we have to do is look at the total. Remember, the mass of each element over the mass of the compound. So what is the mass of the compound? So the mass of the compound is 71.2 grams of nickel plus 35.4 grams of oxygen. That would be a total mass of 106.6 grams. Now let's just take the percentage of nickel, move it down here, equals 71.2 grams over 106.6 grams, which would be the NiO. And that we multiply it by 100, it equals 66.8%. Now we of course can just subtract from 100 to get the oxygen, but let's just go through it. And we have 35.4 grams of oxygen all over 106.6 times 100 equals 33.2% oxygen, and this was 68% nickel. So when you're given the masses, it's pretty straightforward. Now we're going to look at percent compositions from a formula. So let's say we have C6H12O6. We want to know what the percent of carbon is, the percent of hydrogen, and the percent of oxygen is. Okay, so what is that percent of carbon, what is the percent of hydrogen, and what is the percent of oxygen? Now this actually is also using the mole, quite straightforward really. So what we're going to do is say we're going to find these percentages as if we've had 1 mole of glucose, C6H12O6. So in 1 mole of glucose, we can find the percentages. So we look at each individual, the mass of each individual element in a mole. And what really that means is we have 6 carbon atoms. Well, what's 1 carbon atom? 1 carbon atom is 12 grams, and if we have 6 of them, we just multiply it by 6, and that equals 72.0 grams of carbon. Mass of hydrogen, and so we have 12 hydrogens, so that equals, that has a molecular mass of 1.0 times 12, that just equals 12.0 grams of hydrogen. The mass of oxygen in 1 mole would be, so there are 6 oxygens, so that is 16 times 6, which equals 96 grams of oxygen. Now we're going to add these all up. That equals 180 grams. That's the total, so that is what C6H12O6 weighs. Now all we have to do is look at them individually. Let's look at percentage of carbon in glucose. So that equals 72.0 divided by grams of carbon divided by 180 of C6H12O6 multiplied by 100. That equals 40%. So 40% is carbon. Then if we have the percent of hydrogen, that equals 12 grams of hydrogen over 180 grams, C6H12O6 times 100, that equals 6.7% of hydrogen. And the rest you could subtract and add, but that's, or add and then subtract, but we'll just do it this way. We have 96 grams of oxygen all over 180.0 grams of sugar, or glucose, and we get 53.3% oxygen. So let's look at another one. What if we have a mole of CO2? We're going to look at how much of, what is the percentage composition of C and the percentage composition of oxygen. This will be 27%. The oxygen equals 32 grams over 44 times 100. That equals 73%. Now we can use these percentages as ratios to calculate how much of carbon is in another, or oxygen is another mass or amount of carbon dioxide. For example, this is basically saying there are 27 grams of carbon per 100 grams of CO2. This is basically saying there are 73 grams of oxygen in 100 grams of CO2. We can use these ratios to find out amounts of other masses. You can also write that as 0.27, and as a ratio of 0.27, this is a ratio of 0.73, either way. So let's look at an amount. Let's say that we have 250 grams of CO2. We can ask the question, how many grams of carbon and how many grams of oxygen would this be? Well, we can just use this, either this ratio or just this, to find out that question. So we just start with 250 grams of carbon dioxide. We multiply it by the percentage. Now we can do this in a couple ways. We can just do this as the first example, or the first where we have 27 grams of carbon per 100 grams of CO2, and that will give us our amount because the grams of carbon cancel out. We get 67.5 grams of carbon in that 250 gram of carbon dioxide sample. Or, by the same token, we could have just taken that 250 grams of carbon dioxide and then multiplied it by 0.27, because that's what it is. 0.27% is carbon, and we will get the same thing. It's the same way, either way. Now, if we want to do 250, want to find the oxygen, 250 grams of carbon dioxide, and we multiply that by there's 73 grams of oxygen per every 100 grams for 100 grams of carbon dioxide, and so that should come out to be 182.5 grams of oxygen. And again, we can still just, this comes out to be 0.73 anyway, so we could have just, to begin with, just multiplied that by 0.73, and we would have got the same thing.